Welcome to the Suspension System Operation course. In this course, we will cover suspension types as well as suspension components and their purposes. Upon completion of this course, you will be able to identify types of suspension systems, suspension system components and their purpose, including springs, shocks, and struts. Upon completion of this module, you will be able to identify the purpose and various components of suspension systems, including springs, shock absorbers, McPherson struts, and other components. Nearly all suspension systems use springs as a basic component. Springs support the weight of the vehicle, maintain correct ride height, and absorb shock. Vehicle design and available space dictate the location of springs in the suspension system. There are various types of springs: lighter springs for passenger cars, heavier springs for trucks. We'll discuss coil, leaf, torsion bar, and air springs. When weight is applied to a vehicle, coil springs compress. Because the coils have a natural tendency to resist compression, they dissipate energy by trying to return to their uncompressed state. Springs are rated by the amount of force required to compress them 1 inch, usually expressed in pounds per square inch, or PSI. Two terms are used to describe spring movement. Jounce occurs when a wheel hits a bump and moves up. Rebound occurs when a wheel hits a hole in the road and moves downward. Coil springs are typically mounted between the lower control arm and chassis and permit the control arms and wheels to move up and down. The upper control arm is often shorter than the lower one, pulling the top of the tire inward during upward suspension travel. This increases tire life by reducing tire scrubbing often associated with making and breaking road contact. Coil springs may use fixed or variable rate designs. In a variable rate design, one end of the spring is either wrapped more tightly, made from different gauge steel, or has a different number of windings than the other. The variable rate design enables coil springs to handle both light and heavy duty loads without sacrificing ride quality. A variable rate spring can have a combination of coil wire size and unequal spacing. The spring rate varies. A fixed rate spring has one size coil wire and one basic shape with even spacing. A fixed rate spring has a constant spring rate. Coil springs eventually sag because of age and deterioration. A sagging spring will affect vehicle ride height, wheel alignment angles, steering angles, braking, tire wear, and wear of other suspension components. Spring maintenance is normally a replacement effort. Check for a tag or part number stamped on the old spring. Examine the spring to determine the type of end it has: full wire open, tapered wire closed, or pigtail. Check your catalog closely to ensure the replacement is the correct spring for the intended use. Caution: anytime service is performed, the spring tension must be unloaded. Use a coil spring compressor to release the tension. Leaf springs connect the axle to the chassis and are found on light trucks, SUVs, vans, and a few passenger cars. They have a good load carrying ability. A monoleaf spring is a thick arched strip of steel or other composite that tapers off at each end. A multi-leaf spring has multiple layers of spring steel stacked together in the shape of an arch. Generally, one main leaf is attached to the chassis in shackles using spring eyes. Progressively shorter leaves supporting the main leaf are held together by a rebound clip at the ends and a centering pin in the middle. Material may also be added between the leaves to reduce friction and noise. When weight is applied to the vehicle, the springs compress. The shackles allow the arched leaves to flatten during their stroke. Because the leaves have a natural tendency to resist flattening, they support the vehicle's weight by trying to return to their original position. Caution: anytime service is performed, the spring tension must be unloaded. Raise the vehicle so the drive axle is suspended. Some leaf springs provide two-stage resistance with a lighter first-stage spring providing a comfortable ride and more rigid second-stage springs increasing weight-carrying ability. Leaf springs are strong, enabling them to control body sway and resist lateral movement. Torsion bars are spring steel shafts that are usually attached to the vehicle chassis and the lower control arms. They are lightweight, compact, and provide greater resistance than equally stressed coil springs. They can also be used to adjust ride height. When motion from varying road surfaces is transmitted to the control arms, they move up and down, twisting the torsion bars. Because the torsion bars have a natural tendency to resist the twisting motion, they react to the motion by trying to return the control arms to their resting position. Caution: anytime service is performed, the spring tension must be unloaded. Air springs are an alternate type of spring that can be used in place of coil springs. The air spring is a rubber cylinder filled with compressed air. Drag each set of terms on the left to complete the statement on the right. When finished, select Check Answers. Choose the correct answer for the question. When finished, select Check Answer. Choose the correct answer for the question. When finished, select Check Answer. Choose the correct answer for the question. When finished, select Check Answer. If unrestrained, springs continue expanding and contracting after a blow until all the energy is dissipated. Shock absorbers, which are usually attached to the chassis and lower control arm, minimize the effects of suspension movement to the vehicle body. Shock absorbers are either oil-filled or gas-charged. Oil-filled shock absorbers use pistons moving through hydraulic fluid to dampen oscillations created by the springs. They also dampen accelerating and braking pitch. Shock absorber resistance occurs through a combination of hydraulic fluid viscosity and piston valving. Gas-charged shock absorbers include an inert gas under pressure, separate from the hydraulic fluid. The gas prevents fluid aeration and foaming during adverse operation. The shock absorber is a sealed unit divided into an upper and lower chamber by a piston. Spring jounce and rebound cause the piston to move up and down. The piston's movement through the oil absorbs the energy of the spring, causing the spring energy to diminish. The slowing piston movement is created when fluid is forced through calibrated openings between the upper and lower chambers. The shock absorber is mounted vertically or at an angle, which improves vehicle stability. Shock absorbers on high-end luxury and sport vehicles may have an adjustable dampening rate. An electronic or manual adjustment can make the shock react slower or faster. Shock absorbers are not serviceable and should be replaced if oil seeps. All shock absorbers are dual acting, which means they deliver resistance on both the compression and extension strokes. The shock absorber generally produces less resistance during the extension stroke. Dual acting shock absorbers stop spring oscillations quickly, improving directional stability and reducing tire wear by keeping the tires in contact with the road. The air shock assembly is an air assisted system. The upper chamber of the shock can be charged with air. The air shock provides the ability to adjust ride height, assisting the springs and compensating for heavy loads. This type of shock is most often used in minivans. The assembly's main components are the air shock, air lines, compressor, air dryer, and height sensor. Choose the correct answer for the question. When finished, select Check Answer. Choose the correct answer for the question. When finished, select Check Answer. Choose the correct answer for the question. When finished, select Check Answer. McPherson struts combine the shock absorber and coil spring into a single structural unit. McPherson struts attach to the upper portion of the steering knuckles and to the strut towers on the vehicle body. A bearing plate is usually installed on top of each strut to allow the entire strut to pivot when steering. The bearing plate serves the same purpose as an upper ball joint. The top of the steering knuckle is attached to the lower portion of the strut. This eliminates the need for an upper control arm. Because the upper control arm is eliminated, McPherson struts are designed to withstand the vertical and lateral forces that the upper control arm would otherwise absorb. A McPherson strut installation is a single assembly, including the spring and shock absorber. The strut is mounted at a slight angle. The top of the strut is mounted to the body. The bottom of the strut is fastened to the knuckle or spindle. Caution: anytime service is performed, the spring tension must be unloaded. Choose the correct answer for the question. When finished, select Check Answer. Choose the correct answer for the question. When finished, select Check Answer. The upper and lower control arms provide mounting points between the chassis and the ball joints. The control arms allow the suspension to travel while maintaining suspension geometry. The upper control arm is shorter than the lower one, pulling the top of the tire inward during upward suspension movement. This increases tire life by reducing tire scrubbing, often associated with making and breaking road contact. Ball joints consist of a ball and a socket. The upper ball joint connects the upper control arm to the steering knuckle, and the lower ball joint connects the lower control arm to the steering knuckle. The ball joints rotate, allowing the steering knuckle to turn and pivot as the control arms move up and down or the steering wheel is turned. The knuckle is positioned between the upper ball joint or strut and the lower ball joint. Its purpose is to provide a fastening point for the other suspension components in the front of the vehicle. The knuckle is referred to as a steering knuckle when it's designed to pivot. Drag each component to the correct description on the right. When finished, select Check Answers. The hub assembly is a sealed unit consisting of the hub and bearings and is fastened to the knuckle. It is typically found on front-wheel drive vehicles and replaces the spindle that's used on rear-wheel drive vehicles. Bushings attach to and insulate suspension components, absorbing sudden suspension movement and isolating the body from noise and vibration. If a bushing is worn, it transfers noise and vibration to the body and may also cause poor suspension performance, poor directional stability, and an inability to properly align the vehicle. Improper tightening of a bushing can cause poor performance and premature failure. Torque all bushings to manufacturer's specifications. The stabilizer bar or sway control bar is made of spring steel and is attached to the vehicle chassis at the middle using bushings. The ends are attached to matching suspension components on each side, such as a control arm or strut. The stabilizer bar attempts to keep the vehicle's body level by transferring force from one side of the vehicle to the other. It applies an equal opposing force to the same suspension component on the opposite side of the vehicle. When the front wheels encounter a bump and both springs deflect or compress equally, the stabilizer bar moves inside its bushings with no opposing effect on the control arms. When one spring compresses and the other expands, the stabilizer bar functions like a torsion bar spring. It connects both sides of the front or rear suspension by twisting and transferring the force to the same suspension component on the opposite side. The opposing twisting force from the suspension movement on the other side of the vehicle dampens body sway. Stabilizer links are rubber, plastic, or metal links that connect the stabilizer bar ends to the control arm or strut. On some vehicles, the control arm attaches to the chassis at a single point. This suspension type requires the use of a strut rod to maintain the control arm's fore and aft positions. The strut rod attaches to the knuckle or control arm and the chassis. The trailing control arm connects the axle to the chassis or body in the vehicle's suspension. A kingpin is normally found on older two-wheel drive trucks 1 ton or greater. The kingpin is the main pivot in the steering mechanism, allowing for side-to-side pivoting. The use of a kingpin in conjunction with a straight axle or independent I-beam allows the suspension to support more weight. Choose the correct answer for the question. When finished, select Check Answer. Choose the correct answer for the question. When finished, select Check Answer. Choose the correct answer for the question. When finished, select Check Answer. Choose the correct answer for the question. When finished, select Check Answer. In this module, you have learned to identify the purpose as well as the various components of suspension systems. Upon completion of this module, you will be able to identify the different suspension types, including independent suspension, fixed axle suspension, semi-independent suspension, and air suspension. An independent suspension system allows the individual wheels to move up and down separately from each other in response to the road. This system provides improved ride, steering control, and stability. Since each wheel is independently connected to the chassis, it does not transfer its movement to the other wheels. Most independent suspension systems have the same basic components but can be assembled differently. The short arm and long arm, or SLA independent suspension system, typically consists of the components listed on your screen. The rubber and metal portion of the stabilizer links connect the stabilizer bar to the control arm. The torsion bar independent suspension system typically consists of the following components: torsion bar, upper and lower control arms, stabilizer bar, stabilizer links, knuckle, strut rod, bushings, and ball joints. The McPherson strut suspension typically consists of the following components: McPherson strut, coil springs, stabilizer bar, cross member, and control arm. The modified McPherson strut suspension has a coil spring that's mounted separately from the McPherson strut. The strut replaces the upper control arm. In addition to the McPherson strut and coil spring, this suspension has a knuckle, a ball joint, a lower control arm, and bushings. The twin I-beam replaces both control arms at each wheel. A twin I-beam suspension typically consists of the components listed on the screen. The strut rod limits the fore and aft movement of the I-beam while allowing up and down movements. Note that in older I-beam suspensions, a kingpin replaces the ball joints. Choose the correct answer for the question. When finished, select Check Answer. Choose the correct answer for the question. When finished, select Check Answer. Choose the correct answer for the question. When finished, select Check Answer. The purpose of the fixed axle suspension is to carry more weight. This suspension is found on light trucks or full-size cars and often has leaf or coil springs on the rear axle. A fixed axle suspension has the components listed on the screen. On a fixed axle suspension, wheel movement transfers from one wheel to the other through the axle. Select the play button to see suspension movement. When finished, select Next to continue. Choose the correct answer for the question. When finished, select Check Answer. Semi-independent suspension systems are used so that the reaction from one side of the axle won't be fully felt on the opposite side. On this type of suspension, the axle tube can flex. The semi-independent suspension typically consists of the components listed on the screen. The lateral bar is used to reduce side-to-side movement. Semi-independent suspension systems are often used as the rear suspension on front-wheel drive vehicles. A cross-member or torsion axle is used to connect two trailing arms. Even though there's a solid connection with the cross-member and the trailing arms, the cross-member will twist with each up and down movement of the wheels. This twisting action stabilizes the ride and provides semi-independent movement. Choose the correct answer for the question. When finished, select Check Answer. An air strut assembly suspension has a rubber diaphragm that replaces the coil spring. Additional components are used to control ride height. An air suspension can be controlled and varied. An air component can be incorporated into the McPherson strut suspension. The air strut assembly has pneumatically controllable struts and electronic height sensors. Some systems use 4 sensors, one near each wheel assembly, and some systems use 3 sensors, 2 near the front wheel assemblies and 1 on the rear axle assembly. It also contains an air compressor with a dryer assembly, air lines between the compressor and air strut assembly, and solenoids, 1 for each air strut assembly. Caution: anytime a service is performed, the air suspension must be electrically deactivated and rubber diaphragms must be deflated prior to performing service. Like an air strut assembly, an air spring assembly suspension can be varied. It also has additional components to control ride height. An air spring assembly can be used in place of any coil spring suspension type. The air spring assembly has pneumatically controllable diaphragms and electronic height sensors, 2 in front and 1 in the rear. It also contains an air compressor with a dryer assembly, air lines between the compressor and air spring assembly, and solenoids, 1 for each air spring assembly. Drag each term on the left to complete the statement on the right. When finished, select Check Answers. Drag each term on the left to complete the statement on the right. When finished, select Check Answers. Congratulations, you have successfully completed the Suspension System Operation course. In this course, you have learned to identify types of suspension systems, as well as suspension components and their purposes, including springs, shocks, and struts.